I'm now handing it over to Sharik. Sharik, are you with me? Arun?
Yes, Sunita, it's 2 minutes joining. Sharik is ready. Sharik, your voice is not audible.
Yes, sir. Your voice is audible.
Hello.
Hello.
Yes, who's this?
Yeah, this is Krishna.
Yes, Krishna, we'll be just beginning in a moment.
Okay, sure.
Yeah.
अरे भाई नहीं तो निकल जाओ।
तुम्हारा मेल आना नहीं किए?
तो करो आप फोन जल्दी।
तो मैं चढ़ जाओ, अंदर चढ़ जाओ, मतलब बैग लेके चढ़ जाओ, अल्लाह निकल लग जाओ। If you don't mind. So I'm audible now, guys, to everyone? Okay, thank you. Hey guys, I'm really sorry. There was some issue and my voice was not audible to all of you. Let me just quickly share my screen and please confirm if you can see the presentation here. Quick show of hands, please. Can you see the presentation? Great. Superb. All right, so thank you and apologies once again. We are already like around 12 minutes past our scheduled time, but hopefully we are not going to waste any more time. So welcome once again, guys, to this DevOps webinar. And I'm not sure if Sunita was able to give the presentation, but this webinar is more about DevOps. We'll take a look at what exactly we are going to cover in the next about an hour or 15-minute session. My name is Sharik, and I have 11 plus years of industry experience. For the past 5 years or so, I am working as a trainer as well. I have done trainer consultation with regards to DevOps and cloud and all these things. If you talk about the specific technologies, what I have worked on or what I have experienced on, those would be some of them would be Chef, Puppet, Ansible. We have Docker, Kubernetes. If we talk about cloud, then it would be AWS is one of the primary cloud which I work upon, but I do have experience on OpenStack and IBM Software as well. I'm not sure how many of you are aware about IBM Software. What we know as today is IBM Cloud, was earlier known as IBM Bluemix, and before that it was Software. Okay, and just a quick kind of to set the rules here. Since I'm the instructor, I'll be doing most of the talking. If you have any questions, I am able to see your, you can see the chat window, so just type in your questions there in brief, and I will answer all your queries, or at least I'll try to answer as many of them as possible. Okay, so whenever you have a question, just feel free and type the question in the questions pane. I will check it every, let's say, about 10 to 15 minutes once. I'll try and make sure that the flow of the presentation is not broken. If there is anything which I see that it's kind of off the topic or something, I'll take that question at the end of the session. Sounds good? Great. Okay, so if we come back to the presentation, this is how the agenda looks like. So of course we are going to talk about DevOps, what exactly it is, why should we use it, why should we learn it, right? We'll try to present a case for DevOps per se. Then we will talk about some of the very standard terminologies of DevOps. For example, continuous integration, continuous deployment. All of you must have heard of something known as CI/CD. That's like a buzzword in the IT industry. CI/CD, containers. These are some of the things. If you are working in IT industry, you're bound to hear about those things, right? Then we will talk about configuration management, deployment tools. So what we will try to do here, see, this is not exactly a very deep dive tech session. This is more, I would say this is a 10,000 feet overview of what DevOps looks like, what are the important terminologies, what is DevOps comprised of, okay? And as an IT professional, if you are not already into it, why you should be in, right? Because this would be one of the best times to be in the DevOps industry and to understand things and to give your contribution, right? It's beneficial for the industry and for you as well. And of course, if the time permits, I will definitely try and show you some of the demos. I might show you some Jenkins pipeline, or I'll try to show you some Docker commands, some how does it look like in real life, because again, Docker is more like an enigma to a lot of people who have not kind of, experienced it, right? And there are a lot of myths around it, a lot of confusion and myths around Docker and the overall ecosystem. So I'll try to kind of, clear as many doubts as possible. And one thing I would definitely encourage all of you to ask any of the questions you may have, right? This would be a very good time to clear your doubts. I do have some slides to follow, but I would love to answer your queries, and I would love to, understand what is your understanding of DevOps. Okay, and let's make it more interactive. All right, so that brings us to the first section, DevOps and its applications, right? So before we actually move to DevOps, we need to take a small dive into the history lesson, okay? So I'm pretty sure all of you must have heard about something called waterfall model. This was the model which was predominant in the IT industry in the 90s, right? It started somewhere around 80-85 when we started about software delivery, when humankind started writing softwares, right? It was around, I think, 75, 80, around that time we started. And till I would say end of 90s or maybe early 2000s, like 2001, 2002, waterfall was the predominant model when it comes to software development lifecycle, right? Each and every company was following this model. It was pretty hit, it was pretty good, it was doing its job, and there was a reason why it was so popular. But yes, just like any other tool or technology or framework, it had its pros and cons, right? So it served us really well. As I said, a lot of companies, in fact, all the companies, this was the de facto model for if you are working in the software industry, right? Pretty much straightforward. There was a linear progression to it. If you see on a screen, you will be able to see that it was like started with requirement gathering and analysis, where this was the first step where customer comes to you, or you go to the customer and you understand what exactly a customer needs, right? It can be a web application, it can be a desktop application, some service with regards to software, right? Once that part is done, then you do the designing part of it. You kind of come back, you sit with your development team and create sort of a wireframe and design it, right? What exactly should be there, how it should look like. So that is where the design phase comes into picture. Then you do the implementation, which kind of comprises of the actual coding, and when you do the setup within your lab environment or development environment, right? So and once that is done, then you do the testing. Of course, testing is one of the integral parts of overall software delivery lifecycle and DevOps as well, right? If you don't have proper testing framework, you actually cannot achieve DevOps. And then, of course, you deploy it onto the user premises. Now, I'm talking about the 90s, where there was nothing called cloud, right? It was all your infrastructure, customers' infrastructure. So depending on what kind of setup you have done, what exactly are the requirements, most of the times it will be deployed onto the customer's environment, right? The data centers, if it is a big company, the companies will have their own data centers, right? And you deploy the application there, you do this sort of further testing, and a lot of times it actually included giving training to the customer's staff, the people who will be actually working on those softwares. That was again one of the very important aspects of during those times, right? Especially if this is not exactly a standard application. Then of course you will do the maintenance as well. Guys, can you hear me properly? I see one or two guys have mentioned that they cannot hear me. Okay, thank you. So looks like it's the gentleman's problem. So I'll just ask him to re-log in. Thank you, guys. Okay, so as I said, this was the typical structure which everybody followed. Any typical software development lifecycle had these steps, right? So as I said, for about a decade, or more than a decade, it served us really well, and almost every company was following this model. But as I said, it had its own pros and cons, right? Pros was typically that it was very very straightforward to implement. It was not exactly very complex, right? Easy to understand. You can onboard your new developers pretty quickly. But the major problem, one of the major issues with waterfall was that it cannot go back, right? There was no feedback mechanism, right? Let me give an example here. So let's say I'm a customer and you are the developers. So I come to you today, which is like January 2019, and I give you my requirements, and I ask you for a software to be built. Now, irrespective of whether it is a desktop or a web application or anything, I need something. I need an X product, okay? And I give you all my requirements, and you start working on it. And let's say about 6 months time, because 6 months was actually a standard time when we used to work with waterfall model. Today's world, it might look like a very huge time to you, right? I mean, 6 months is a pretty long time, but during those days, 6 months was a very standard time. In fact, it was pretty fast, right? If it is a moderately complex project, it might go 1 year or more as well, right? So 6 months was a pretty standard time. So let's say I come back to you after or around June or July this year. So, and then you give me a ready product. But what happens, and actually it used to happen during that time as well, that by the time you come back with the ready product, my requirement has changed, right? Now let's say want not 5 buttons, I want 10 buttons on my web page, or maybe the whole data flow, how I want it should be different, or maybe there is some approval flow which has to be different, right? Instead of 2 approvals, now I want 4 approvals from 4 different management people before something goes for the final production, right? So anything, it can be anything. But the idea is that requirements do change, right? And in today's world, if you see, it changes even more quickly, right? So it is completely unacceptable in today's world that I come and give you the requirement and we don't talk for 6 months and then you come back with a ready product. That's not possible, actually. In fact, that brings me to a question. All of you are using all of you are using the smartphones, right? iOS or Android or Windows. Okay, so the question is to all of you, what exactly is the frequency? Take a typical app on your mobile phone. Take any app, right? And tell me, what is the typical frequency when you get an update for that application? Is it in weeks or days or months? How is it? Any ballpark figure? Okay, I got some really different answers. So week, minutes, months, weeks, and months, weeks. Okay. Okay, so what I'm traditionally getting, I mean, most of the people are giving in weeks. So I would also agree, if you take a single application, let's say Facebook, almost everybody has Facebook on their mobile phones, right? So on an average, every 1 week or every 2 weeks, you get some or the other update. It can be some small update, or it can be some big update as well, right? And whenever you get an update on your mobile phone, the applications, mobile applications, you would all understand, right? There are a lot of things which goes at the back end, right? Today we work on something called, we'll talk a little more on that. We call it as feedback mechanism in Agile and DevOps. So what happens, you provide the feedback to the company, and company says, okay, we should have this feature. A lot of users would like to get this kind of feature, right? So let's say some button or some scroll or some sort of visualization which you would like to be in a different way, right? So that is something which goes back to the developers in the form of a feedback loop, and it goes as a backlog. I'm not sure how many of you are familiar with the Agile terminologies, but we call it as backlog. Okay, and backlog eventually becomes a user story, and then eventually it becomes, you know, a coding task for one or two of the developers, depending on how complex or easy it is. Okay, so what happens now is that whenever you are getting a single update, that means that there has been a development being done on that particular software or a feature. It has been tested a number of times, right? And sometimes it has been tested thousands of times before it actually reaches the end users, right? And then finally you are getting in the form of an update. Now it can be a minor update or it can be a major update, right? So this feedback mechanism, what we have today in Agile and you know, DevOps, it was not possible in waterfall model, right? Because we did not have the mechanism to take the feedback. Once we take the requirement and gathering analysis, once we do that, it's over, right? Customer does not have a say anymore. This was one of the major drawbacks of the waterfall model. And this was the reason it gave way to something called Agile. Now, Agile, actually, it worked in something called feedback mechanism. So we had this system where, you know, you don't give the whole product in a single go to the customer. Rather, what we will be doing is that we will take a couple of things. We will give some sort of skeleton to the customer, and then we will collect the feedback. Okay, you want this, we'll give you. So let's say if the customer has given 10 requirements, A, B, C, D, and E, F, G. So A, B, C, we will give in one go. Then E, F, G will give in the second go. H, I, J will give us in the third go, like that. So one by one. So one or two or three updates will given constantly. The advantage of it is that when you do that, you actually first thing is that every frequent interval you are giving some ready product to the customer. That is one advantage. So customer has a feel of it, right? He or she can check and then they can decide on it. Okay, so I am getting something. That satisfaction factor comes here, right? That is one thing. The second thing is that this is the way where you get the feedback as well. So let's say you provided feature A, the customer might like it or the customer might not like it as well, right? So in both the scenarios, you get the feedback. Okay, so let's say the customer did not like it. We have to make, let's say, ABC changes here, right? Some changes. The customer said, okay, no, I don't want the blue background. I want green background, right? So of course, you have that option now. Since you're getting that feedback, you can actually give it back to the customer in the next sprint cycle, right? So that is what the major advantage of Agile was as a framework, and that is why it became so popular in a very short span of time. So as I said, 90s was a time when waterfall was extremely popular. Somewhere around 2001 or 2002, it was the time when Agile Manifesto was written and people started and implementing or adopting Agile practices into their software delivery life cycle. And within very short time, I think within a year or so, it became very popular. People started seeing the benefits of it. And okay, so I think people can read it. If you're not able to hear, just press the call button. Okay, so coming back, so the thing was that in waterfall model, you had a ready product in 6 months time, whereas in agile model, now you are able to provide the customers some ready product or some, let's say not a big full product, but some feature or some functionality within that product every 15 days, let's say, because typically if you see agile, we have something called a sprint. Okay, now a sprint is basically a cycle. So it's a cycle of when you get the feedback and then you provide some ready functionality to the customer. And typically it varies from 1 week to 4 weeks, right? And the most common one, what I have seen is 2 weeks. So 10 working days rather is the time when you actually you follow a sprint. So every sprint is one cycle. So let's say you start on 1st of January, you start working on some product. By 14th or 15th of Jan, whenever the sprint ends, you have something ready which you can give back to the customers, right? And then you take the new functionality or feature request and you give it again. Maybe you take some bug fix next time and you fix it next time in that particular sprint. So that's how it goes on and on and on. Right. So, how many people are here from the operations background? And when I say operations, anybody who is doing, let's say, VMware or Windows or Linux or networking, storage, right? Anybody who is helping me running my data center. How many? Okay, I see Linux admin. Couple of more guys. And how many of you have done deployments? Maybe you're doing it now or you have done it in the past. Okay, so I see one guest who is doing JBoss deployment. Okay, a lot of guys now. Okay, great question. Like a lot of people are there from integration team, application support. Super. So this question goes to all of you. We spoke about waterfall model. We spoke about Agile. We have not come to DevOps yet. Okay. The question is, what problem or what challenge you see from the operations perspective? Now, this is related to deployment, by the way. People who have done deployment, what would be that one big challenge you would see? Let's say if you're the application team which you're supporting, the developer team, they moved from waterfall to Agile. Okay, thank you guys. I see a lot of you are from the admin background, the sysadmin and operations and all. So yeah, the question again, what will be the challenge if the team which you're supporting, they move from waterfall to Agile? That one big challenge. Deployment issues. Well, deployment issues will be there, right? Building issues. Again, how would it make a difference if it is from waterfall? Also will have building issues. Waterfall will also have deployment issues. Agile will also have deployment issues. Something which would not be there in waterfall, but which would be there in Agile. Doesn't have feedbacks. That's right, but how does it matter to the ops team? I'm asking from ops perspective. If you're part of, let's say, yeah, one person has said timeline issues. Can you elaborate a little bit on that? Way of planning. Okay, you guys are actually good guesses, but again, not exactly the one I'm looking. Gentleman who said timeline issues, can you give some other word what exactly you mean by timeline issues? Probably you are the closest. Every day we can't deploy. Super, that's what I was looking for. As an ops person, as a person who is doing deployment on a daily basis, who is doing deployment for your application team. Now, people who have done deployment, I think you would all agree with me on this point. Let me know if you don't agree as well. That deployment is something which is happening the day or the week or the month in which deployment happens. What happens is, like, the whole team will be awake. Probably that weekend you're supposed to spend in office, right? Or maybe you have to stretch for a couple of hours, right? So it's quite happening. The whole floor will know that, okay, team X is doing deployment today, right? Probably you will get the pizza at the end of the day. That's fine, but it's quite big, right? That to midnight every night. That's correct. So thank you, sir. So that's the thing. The main important point what I want to convey is when you move from waterfall to Agile, in waterfall model, you have to do deployment every 6 months. That's the frequency. But if you are following the Agile model, let's say your developers have come to Agile model now, then the deployment frequency becomes every 15 days. Now, if I'm your manager and if I tell you that, whenever deployment happens, that day you have to either stay at an office for the midnight, or you will go, let's say 3-4 o'clock in the morning, you will go back. So I don't think you will face, you will revolt to that if it is once in 6 months. That's fine. You can manage with that, right? But if I tell you to do that every 15 days, then of course it becomes a problem. right? So that is one of the reasons how DevOps came into picture, because from waterfall, when we moved to Agile, Agile made the developers very productive, much more productive than what they were before, right? So they can write and they can actually give you some ready product every 15 days. Now that was not possible before, right? But at the same time, it created a lot of problems from the ops perspective, because as an ops person, you cannot deploy just every week, because deployment requires a lot of other things. It requires a change window. It requires some lead time. It requires post-deployment tests, right? One gentleman is telling, in my previous company, daily deployment happened through auto deployment process. That's what you achieve. So probably in your last company, DevOps was already being followed, maybe not completely, partially, right? So if you're doing DevOps, if you're doing deployment daily, that is something I won't say impossible, but very, very, very difficult if you're not following DevOps methodologies, right? So I'm sure your company would be following DevOps tools and methodologies. Yeah, so coming back to the concept of it, so what happens is, because of this frequency, this whole thing, what happened, DevOps came into picture, because developers were now very fast, but ops guys are still facing this problem. They cannot do the deployments on a daily basis or a weekly basis also. And what used to happen, that let's say I'm the developer, I have written the product, right? But even then, since ops, they have a backlog, they have a kind of bottleneck, they are not giving me time slot to deploy the application. So even if I have completed the software today, let's say my deployment window comes, let's say on 31st of January. So even though everything is ready, I cannot get the benefit, because when is your product getting the benefit? When your end users are going to use it, right? And that is going to happen only when your product is, or your application is deployed onto the prod servers. Without that, you don't get the benefit, right? So there was a bottleneck created, which actually was not helping Agile in the best possible way. So that's the reason what happens. Agile without DevOps, you would see that it is incomplete, okay? Because no matter how quickly you can write the software, unless it is deployed onto the production machines, it doesn't give you the exact benefit of it, right? And that is the reason actually you will find a lot of similarities between Agile and DevOps. In fact, there's one very common question which I ask in interviews pretty often: what is the relation between Agile and DevOps, right? And the answer should be in this format, that Agile is to developers, DevOps is to ops folks, right? And DevOps starts where Agile stops. Because you talk about continuous integration, okay? We'll have a slide where we talk about CI, but CI is all about continuous testing. What next? Right? You do delivery, you do deployment, you do deployment on UAT, you do deployment on staging servers, right? There are a lot of other things which you do, right? All those things will not be possible if you don't follow the DevOps methodologies, right? Okay, so this screen brings me to one more question. How many of you have sat on a SEV1 or a P1 call? And if yes, if the answer is yes, there is a follow-up question. The follow-up question is that if you have sat in that P1 call or a SEV1 call, what is the first instinct of anyone? Now that is irrespective of which team you're representing, right? If you talk about a P1 call or a SEV1 call, you will have people from ops side, networking side, app developers, application support, project managers, you know, anybody can be there. All these stakeholders will be present in that P1 call. Right. So what is that first instinct? Right. Let's say some from your ops team or like NOC team, right? People will call you that there is an application down, and you are pulled into that call. Some guys are already there from some other teams as well. Maybe geographically different places they are joined from. What is that first instinct which you will do as an engineer or as a manager? Issue facing, yes, you will find that. You will try to find that. But that's the end result. That's what you will do eventually. You want to find the issue and fix the issue. That's a given. Sprint meeting. Why would you do a sprint meeting in a P1 call by? I don't think that's the right place to do. Version check, yes, you will do. Check memory. Yeah, these are troubleshooting. I'm not talking about troubleshooting. You will do all these standard things. You will check your app. You will check maybe memory and latency and all these things. That's there. Involve the teams. That's done. Teams is already involved. Let's say there are 5 or 6 different people and each person is representing some or the other team. What is the impact? Yes, you will take the impact. You will check the impact. But after that, we'll check the latency. No, you're going into that troubleshooting mode now. Before you start troubleshooting, there is one I'm talking about the instinct. What is your first instinct which you follow? Record the problem incident. Yes, I think that's okay. In some cases, yes, it will be there. Yeah. Priority. Okay. I think we don't have enough time to do this exercise. So what I'll let me make it easy for you. I mean, that's what my understanding is. That's what I have seen. I have faced. I'm telling you from my experience. And let me know if you don't agree with me as well. Okay. The first instinct, if I am, let's say if I join a call and let's say I'm representing networking team or let's say app supporting, the first instinct for me is to make sure the problem is not because of me or my team. Do you all agree with me? Okay, so I got a lot of yeses, so one no. So the person who has said no, can you say why? That's an instinct, by the way. That's, again, I'm not telling that's the right behavior. Okay. That's what we try to avoid, but that's the first instinct. We are one team. I mean, I wish that was true for most of the companies or the projects, right? And that is something which DevOps tries to bring. In fact, at this point in time, I would like to give you one keyword. When you get time after this webinar or whenever, today, tomorrow, whenever you get time, just search on Google something called 2 pizza teams. Okay, just go and search for it and read the first few articles. Just go and take a look at what exactly this is all about. Okay, so what happens when I say, the reason I cited this example for you is because the normal tendency as a human being or as engineers, what we try to do is we first try to make sure the problem is not because of me. So when I say that, what I try to make sure, let's say if I'm from the networking team, so I want to make sure the problem is not because of networking. Network is doing fine. Okay, the network does not have any issue. So what I do, I try to isolate. Let's say if it is one application, application A, I will check how is application B is doing. If application B is doing fine, that would mean that, and if they're on the same network, then of course the network is fine. That's how you isolate problems, right? In a typical 7 or P1 scenarios. So what you do is you actually isolate the problem. So if let's say if I'm the VMware infrastructure owner, and let's say I have 10 different hosts, 10 different virtual machines on a host. So what I'll do, if let's say if let's say application A is problematic, I'll check any of the virtual machines of application B. Again, the same process, right? I try to isolate where exactly the problem is. Right? And if let's say I am the VMware infrastructure owner, my host is up and running, the virtual machine is up and running. So I can safely say that, okay, boss, my host is working fine, the VM is working fine, it is responding, I'm able to SSH, whatever. I'm able to hit the API endpoint. Now the problem is something with your application, or the problem is something with related to storage, right? So that's the typical tendency. That's what we call as blame game, right? So this is something, if you see here, and again in the slide, you'll see it from 2 perspectives, dev and ops, but it can be applied to anyone, right? Networking or storage or QA, anyone. QA is typically not no, because QA is you test and you get the results, so you don't very often get involved in a P1 situation, right? So if you see from the dev side, typical blames are like, or rather what you want as a dev person. You don't want legacy systems. You want like up and running the systems which are completely updated and everything. The tool turbulence, so you want proper tools and technologies to work. And you want a lot of automation, right? The same thing if you are from the off side, you will tell monitoring is not that good, we need something to fix it. And you will directly say to the devs, boss, go and fix your bugs. It's the bugs which are giving problems, not my infrastructure, right? So the whole idea is the blame game. Person A is blaming on person B is blaming on person A. That's how it works. And that is, I mean, again, this is my experience, what I have seen. I wish I had a better experience, but what happens for the first 10 to 15 minutes when you are in a 7 or a P1 call, people simply try to isolate. Okay, if this is not because of me, I'll simply chill, I'll relax, right? That's not the right approach. That's not good for business, right? And that is what we try to avoid if we are following the DevOps model. So we don't say it's a problem, I mean, it's a problem for person A or B, or team A or team B. It's a problem, it's a business issue. Business is getting affected. And if the business gets affected, we all are going to get affected. So let's fix the problem. It's not that you fix the problem. That's what the approach has to change, and that is what Two Pizza team talks about. So that's the reason. Whenever you get time, make sure you read about it. Right? That's a very interesting concept. It's been given that the terminology was given by Amazon CEO Jeff Bezos, and it's diligently followed in Amazon and a lot of other high velocity companies such as Google, Facebook, Etsy, Netflix, etc. I mean, all these companies are the ones which has Two Pizza, the pizza we eat, right? So Two Pizza team, that's right. Yeah, so all these companies, if you see DevOps, DevOps, if you see in the industry, last 4 or 5 years, it has become very popular. People have started talking about it. They want to adopt it and all, right? But if you talk about companies like Amazon, Google, Yahoo, or Etsy, Netflix, Facebook, Microsoft, they have been doing it for so long, like at least 10, 15 years or more maybe. Right? The only thing was the name was not there. There was nothing called DevOps, but they were still following these practices even then, right? And they have mastered it to such an extent that we follow it now from there. So if you see, a lot of tools and a lot of practices will come from Amazon. A lot of practices will come from Google, how they work on it. A lot of practices will come from Netflix, right? A lot of tools have come from these companies. I'm not sure if you have seen something called Chaos Monkey. This is a tool, or this is a practice where what happens, in order to test things, you will purposely delete one server, or you will purposely stop one application on one of the nodes, and you will see the behavior, and you will check how quickly you can come back, right? So that is known as Chaos Monkey. Right. So yeah, so the whole idea was that we need to get rid of this blame game, which is very common if you're not following DevOps. And DevOps, we also call silos or barriers, right? So the whole idea of implementing DevOps in your company, or in the project, is to get rid of these silos or these barriers. Okay, you want to work as a one single team, right? If you're working as a single team, of course, you cannot blame anyone per se, right? You can blame only if you have another team. Sure, I'll put the name. So some of the terminologies which I spoke about. Yes, I think one gentleman has put. In fact, I'll give you at the end of it maybe. Are you all able to see my screen? So this is the one terminology I spoke about to pick the teams. The companies which I was talking about, make sure you follow these blogs, right? This will be very helpful for you. So Netflix, Google's blog, of course. Google is one giant. Then we have Amazon, or just check Netflix DevOps blog or Google DevOps blog, like that. Then we have Etsy is one such company. Facebook, of course. So these are the companies, they have mastered this art of DevOps. We call them, actually they are in IT industry, they are known as high velocity companies. Okay, that's what we call them as. So these are some of the very good examples. You can start with them, and One more would be rack space, right? And this is the terminology I've to given you. Anything else comes to my mind, I'll definitely give you. One more was chaos monkey, which I told you, right? So make sure you check it out. This will give you a very good idea, right? How people work, how the industry is working today. Right. If we talk about containers, today we are like, containers is buzzword, and DevOps and containers are going synonymous today, right? Everything is moving towards containers. Every company, every project wants to implement Kubernetes in their environment. But all this started with Google, right? Google had a project called Borg. Okay, this was about 10 years back. So what they implemented Borg internally, that has been externally translated into Kubernetes. And of course, Kubernetes is an open source project, and that's one of the reasons it has become so popular in a very short span of time. Right, so just read about them. I'm just trying to give you some, to generate enough curiosity about it, right? So this is where we were. The whole idea is to get rid of the blame game, and now I think you would understand what exactly DevOps is. So if you go by the definition, the whole idea of DevOps is it's a software methodology which involves practices such as continuous development, continuous testing, continuous monitoring, continuous deployment, continuous integration, right? Throughout, not just in the software development, but testing, staging, deployment, monitoring, everywhere we try to do it, not just in the development lifecycle, the whole complete lifecycle. Okay, and the whole idea is to make this whole process completely seamless, okay, or at least as seamless as possible. Now, of course, it's easier said than done. You have a lot of things. Again, one of the very huge misconceptions in the IT industry is that you implement a couple of tools. Let's say you implement Chef in your company or in your project. You put some pipelines in Jenkins. You put your source code onto Git, and you have achieved DevOps. I wish it would have been that simple, right? The moment when I gave you the examples of companies like Google or Yahoo or Netflix or Rackspace, these companies have mastered this art or this methodology in years, right? They have been doing it for like 10, 15 years, and then they can say that they are the pioneers of this industry, right? So any decent sized project, I can assure you it will take at least a year to implement proper DevOps, not less than that. So we spoke about this feedback loop, right? So that feedback loop continues in DevOps as well. And if you see, now we have the developers. If you see the bottom of the screen, you have all these blocks, right? So developers build the code, then it goes to the quality assurance checks, all the testing what we have, then it goes to the integration where all the moving pieces of that software are integrated together and tested again multiple times. Then it would be put onto pre-staging environment, pre-prod, prod, or staging environment. Their further tests will be done. The final would be the user acceptance test, and once that is also successful, we have done enough testing on the product or the application. Then finally, we will move it on to the production machines or production servers. Now, production servers, it can be on-prem, it can be private cloud, it can be public cloud, it can be hybrid cloud, and on cloud it can be now containers. Okay, so again, if you see, 5 years back, if I would have told you that you can run your production load on containers, you would have literally laughed at me. Okay, but today people are running their production load on containers, right? And it is pretty, because initially it was, first it became the problem of working on the security issue. Then it came like, whether the containers network will be good or not. Then it was about, how you can manage your containers. So every time, this is how it happens. Is again human tendency. Whenever something new is introduced, there will be a lot of questions. There will be a lot of dissent in the team. We don't want, because we are as a human beings, we are not accustomed. We don't like changes very frequently, right? But today, if you see, they are being done. Security, networking, volumes. One biggest problem with containers was that the volume was not persistent. The data was not persistent. The moment you delete a container, the whole data will be gone, right? So again, that was like a couple of years back. Today we have solutions to most of these problems. In fact, each problem has got multiple solutions in the form of different vendors today, right? And yeah, if you talk about the cycle, we have this continuous feedback loop. So you put things in production, you take the feedback, give it back to the developers, they put something. Then again, once it is developed, tested, and integrated, then it is deployed onto the production machines. And then this loop goes on and on and on. So benefits of DevOps. So again, there are a lot of benefits. These are just some of them, which we have put on slides. The first and foremost is the cross-team collaboration. This is where the blame game comes into picture, which you don't want to have, right? Then, of course, when you have good collaboration, it actually results in better agility. Okay, and better agility means or translates to frequent deployment of code onto the machines or on the production environment, right? In fact, I would strongly recommend all of you to check this one out as well. There is one more thing called State of DevOps report. So the moment you type it in Google, you will find a number of results. This is basically a PDF file. This is a report which gets published every year, starting from 2013 or 12, I guess. Okay, so you will have last 5-6 reports available. 2019, I believe it is yet to come, but till 2018, you will have 5-6 different reports. Go ahead and check them out. Download at least 3 to 4 reports. Each one will be about 30-40 pages of PDF files with a lot of graphics and different sorts of pie charts and all those things. But that will give you a very good idea where we started, what were the problems 3-4 years back, how DevOps helped solving it, how industry is responding to each new functionality or each new, I would say, practice. Right, so continuous integration, infrastructure as code, immutable infrastructure. There are a lot of different things which you need to understand. Right, it will show. Don't worry, it will be there. So just type it there, and you will have a number of them. It should be. Let me just give me a sec. So I think one gentleman has put for 2018. So similarly, you should have for 2017 and 16 and 15 as well. Just type in state of DevOps and let's say the specific year and type in PDF. Right. So Puppet.com is one such company. As we see here, so the second example, you have the PDF report for 2016, right? So just like that, you can actually download. So Puppet Labs, Dora, App Dynamics, a lot of companies which actually sponsor these reports, and it's coming every year. Earlier people were reading it as a hobby, but now IT people and the people who are actually in the IT industry, they actually wait for it to be released as soon as possible. So make sure you check them out. Right, so there you will get a lot of information with regards to as I said, how we started and where we are today and what lies ahead. Right, this whole thing, like past, present, and future, you will see. It will give you a very good insight on a lot of things. Yeah, so coming back to the slide, the second thing or the second portion of it is that you have continuous delivery. Right, so continuous delivery is, again, it takes a lot of effort and time to create that thing. I mean, one of the industry buzzword is one-click deployment. Right, so it's not that easy to achieve as well. Same formula applies here as well, that you spend weeks and months before you achieve that one-click deployment. You have to take care of a lot of moving pieces, bring them together, integrate them, put all the conditions, and then probably after a couple of months you will be able to achieve one-click deployment. right? But the good news is that once you have this one-click deployment, it becomes very reliable, right? Because in general, we are talking about a lot of automation here, right? So automation means the more automation would mean less human intervention, right? And less human intervention would mean more reliability, because when you have human intervention, you are prone to human errors as well, right? And again, when you have routine tasks, the chances of committing error is more, right? When you do something over and over and over again, there would be chances that you make some errors, you commit some errors, and which will result in some outage or some downtime or something like that, right? And that is the reason, if you have reliability, the last block which talks about 50% fewer failures of new releases. So you have more successful deployments and less failed changes. That will be the result of it. Okay, so I have one question: difference between Agile and DevOps. Very good and very important question. And as I said, I think we discussed a little bit about it. When we talk about, yes, we are on the benefits screen at the moment. So yeah, what I was talking about, Agile and DevOps, when you say the difference, as I said, it's not about the differences. It's more about how they are related to each other. Because DevOps, eventually, if you see a lot of principles of DevOps, they have come from Agile. Okay, so they have a very strong relationship. Again, it will be difficult for me to kind of explain everything here. But as I said, what Agile is to developers, DevOps is to operation side. Okay, and they work together. Agile without DevOps is incomplete. As simple as that. Right. So now, sure, I'll repeat. So as I said, what happens is when we say Agile and DevOps, a lot of practices of DevOps, they have come from Agile. Okay, so that is the reason there is a very strong correlation between the two. You should not be comparing them in terms of differences, right? That will not be the right comparison of Agile versus DevOps. We can't do Agile versus DevOps rather, right? How Agile has come into picture and how Agile helps developers get the most out of their work. In the same fashion, DevOps helps the operation side. Again, DevOps encompasses everything. It's not that DevOps is only for the operation side, but yes, it has changed a lot of things for the operations folks than what it has changed for the dev side. Okay, and one line answer is that Agile is incomplete without DevOps. Okay, I would answer that, but again, that is something which you can find easily on Google. What is the major difference between Agile and Waterfall? There are a couple of very fundamental differences, but as I said, one of the major reasons of Waterfall going away and making way for Agile was that the absence of feedback mechanism. In Waterfall, you did not have a feedback mechanism. But for more like, point-to-point comparison, I would suggest you just type in Google and you will get the information. Agile and DevOps deals with coding. Again, coding, it does deal. When we talk about automation, we are talking about scripting. So yes, coding is involved a little bit. But again, DevOps is not all about coding. Okay. But yes, as a DevOps engineer, you should be familiar with at least one of the scripting languages or coding languages. Right. Again, you don't need to be a Java developer or a Python developer, but yes, basic scripting, how a loop works, how do you automate, how do you write glue scripts, that is something which you are expected to be familiar. Not only that, if we talk about the individual tools, so Chef, Puppet, Ansible, they have their own language. We call them domain-specific languages. We talk about Docker. Docker has something called Dockerfile. Docker Swarm and Kubernetes, they work on YAML files, right? So YAML, JSON. So all these things are there. A lot of small I would say, small components are there, and all these chunks together will, help you understand and help you implement and become a good DevOps engineer. I will answer that question in this slide. Which tool is good in the market? So when we talk about DevOps, as you can see on screen, you have a number of tools and technologies. DevOps is not a single tool. It's not a single technology. It's not a single framework which you can just implement and tell that you have done DevOps, right? As you would understand, in software development lifecycle, you have coding, you have testing, you have in fact, you can break down testing into multiple phases, right? You have, I think, easily 6 to 7 different types of testing for a single software or a single functionality. Then you have monitoring, then you have deployment, then you have application performance management. There are a lot of other things, right? So for each one of them, you have a number of tools. Now, to give you an idea how many tools and technologies we are talking about, in fact, before I answer that, any guesses on how many DevOps tools? I mean, that's a kind of a lot of debatable terminology, but if still I will use it. DevOps tools. How many DevOps tools are there in the market? Any wild guesses? Just give me a number. 5, 10, 15, 100, 1000, 12. Okay. Not sure. All right. 15, 5. 5 and 12 it's not possible, guys, because you can see on your screen you have more than that, right? If you look at your screen, you will have Git, Subversion, Jira, Maven, then Jenkins. On your right, you have Docker, Ansible. If you count on a screen, you will have probably more than 10, 12 tools, I guess. Okay, so I'm getting all sorts of numbers, 70, 25, 30, a lot of them are there. Let me show you rather than giving you the answer. So if you go to your browser and on Google, if you type periodic table of DevOps, okay, the first result would be this one from a company called Xavier Labs. They are like one of the consultants of DevOps, pretty good company. They have done a lot of good work in DevOps, I would say. And if you click on the first link, let it get loaded, then I'll tell you. So I have like 30, 50, 25. Okay, so is it visible to all of you guys? It has loaded completely now. Can all of you see the periodic table of DevOps? No? Okay. Strange. Okay, wait. Give me a second. Looks like I've lost my presentation skills. I'm no longer a presenter. Give me a second. Okay, so yeah, is it visible now? Not yet. Can you see the DevOps toolkit slide? Yeah, okay. Somehow I'm not able to share the browser screen. What I'll do, let me just paste it here. The link. Did you get the link? Okay, so just check it out on your screen, right? And if you see there, you will find a number of tools. I think it is more than 100 already. And that's the number. When I say how many tools you have, it's more than 100 already, right? Maybe 120 or something or tool. Now, in this one, if you see, this company has kind of given this good overview of the categories. If you see on the top, you will have things like source code management tools, database automation tools, continuous integration tools, monitoring, cloud release orchestration. All these categories will be there. And for each category, you have typically 5 to 6 names, right? Important thing is that is not the complete list, right? That's just the most popular tools out there. So for example, if I talk about source code management tools, right? The most popular tools out there would be, I would say, Git and SVN, right? Git is perhaps the most popular tool today. When it comes to configuration management, I would say the most popular tools out there would be Chef, Puppet, and Ansible. These three are the kind of dominant leaders in configuration management. If we talk about continuous integration, the most popular tool out there would be Jenkins, without a doubt, right? So that's how the tools have been segregated. And if you see on a screen as well, we have given you most of the standard tools or the most popular tools from each category. So for planning, you have some tools. For coding, you have some tools. When you talk about build, right? So if you talk about the Java builds, the most popular ones are Maven, Ant, and Gradle, right? Testing, of course, Selenium is one of the most popular frameworks out there when it comes to browser-based, application testing. When it comes to monitoring, Nagios is perhaps the most popular tool out there. You do have a lot of new entrants like Splunk and ELK Stack, Prometheus. But yeah, Nagios is still there. It is one of the oldest and is still one of the most popular tools out there. If you talk about operations and deployment and all those things, combined, if you see, of course, you can see Docker, Vagrant, Puppet, Chef, Ansible, SaltStack. These are just some of the names which will come to your mind right at the top. Right. So the idea is to let you know that it's not that one or two tools. It's not like one technology which you can learn and say that you are a DevOps engineer. So the question is, if I'm starting today with DevOps, how do I decide? You see a lot of things on a screen already. So if I tell you that you have to learn configuration management, how will you decide that whether you should start with Chef or Puppet or Ansible or SaltStack? How do you think we will do? Right? So we have already more than 100 tools. So do you think in order to become a good DevOps engineer, you need to learn all those 100 tools? In fact, do you think even that is possible? I mean, I don't know all those 100 tools. I'm working in DevOps for the past 6-7 years at least. I would not know even half of them, what you see on that periodic table of DevOps. How do I survive? Right? So, long story short, what you need to do, first of all, you need to do one thing at a time. Again, you can't learn all the tools at the same time, right? And you don't need to learn all those 100 plus tools in your life. Forget about next 6 months or 1 year. In your life, you don't need to learn all those tools because tools will come and go, right? It's the category which will be there always, right? So source code management is not going to change. It will still remain the same. But yes, how we do source code management, that probably might change. And if that changes, of course, today Git is the most popular tool. Maybe 5-10 years back, it was Subversion, which was most popular. Maybe after 10 years, there will be some new tool which will come into picture. Right? But as long as you understand source code management, it will be easy enough for you to understand and switch. Right? So yes, one person has told terminology is same for all. One tool is enough. So I would not use term one tool is enough, but yes, that is how you should start. I mean, when I started, the first tool I learned was, first DevOps. The first brush for me for DevOps with DevOps was Chef. right? I saw there was something called Chef which could automate things. My first question was, we can automate through scripts. Why Chef? Right? So then when I started working on Chef, I realized, okay, it's pretty good. I mean, there are benefits of using Chef. Then after some time, there was one more project where I saw that instead of Chef, they were using Puppet. So when I checked, I realized that configuration management as a category is very similar, right? It's just that you need to make that switch. Okay, I do task X this way in Chef. This is how I will do it in Puppet. That's how you need to do that mapping, right? So same way, you start with, let's say, in continuous integration, you learn Jenkins, and let's say your project, or maybe you change the company and they are working on Bamboo, or maybe they are working on TeamCity, right? Or maybe they are working on Travis CI. So again, you have a number of tools. So if you know and understand one tool properly, it will be pretty easy for you to move to a different one. For example, if you learn Puppet from scratch, it will take you maybe a month or two before you find yourself decently comfortable. On the other hand, let's say you know Chef already, okay, and there is a requirement, there is a project for which you need to learn Puppet as well. That time, probably you can be up and running with Puppet in a week's time as well, because you already know the nitty-gritties of the tool of configuration management. You just need to understand the syntax of Puppet. Right? It's just like the programming language part. Your first programming language is always the toughest to learn. That's the greatest learning curve you will ever face. Once you have learned one language properly, you understand the logic, you understand the syntax, learning the second one is comparatively very easy. The same thing applies here as well. Okay, so again, when you say which tool is best with current market, which category of tool you're talking about? Is it source code management? Is it continuous integration? Is it configuration management? Right? So you have to see from that perspective to give at least some answer to your question. If you talk about source code management, Git is the best tool. If you talk about continuous integration, Jenkins is the undisputed leader. If you talk about configuration management, probably there you have the toughest competition, and Chef, Puppet, and Ansible, they all are, I would say, equally popular. Okay. In recent times, last 2-3 years, I have seen Ansible going extremely popular. Earlier, it was not that popular, but now it is also giving tough competition to Chef and Puppet. So Chef, Puppet, Ansible, they both, all three are like, I would say at the same level. Depends on your company, your project, and your ease of learning. Right. Again, just to give you one suggestion, if you have no idea on any of the configuration management tool, I would say Ansible is the easiest to learn. Right. To start with Ansible. So just to give you some idea on that. Okay. Monitoring, as I said, Nagios is one of the long-standing and extremely popular event today. But the recent ones, for example, Splunk, ELK, Prometheus, and all, they have also, Datadog is one very popular tool nowadays, right? Especially from the containers perspective. So it depends on you, right? And the project. I think that is what we're talking about here. We have this course on MICS, which will help you learn a lot. Probably this question you can park it once we hand it over to Sunita or the Magna backend team. They can answer this question to you, right? Which materials and all these things. Okay, so continuous integration. It's a practice where developers they write the code and they test it. So again, I mean, it's a pretty big topic. Normally, I take about an hour or so to make you understand continuous integration. But the long story short, or in the shortest format, I can make you understand that the moment you write something, the moment you commit or save your code, it will trigger automated set of tests, and you will get the results immediately within a couple of maybe minutes at max, right? So you don't have to wait for the QA folks. You don't have to wait for somebody else to write the test cases and then kind of run those tests and give the results to you maybe in a week's time or maybe 2-3 days afterwards. You get the feedback immediately of your code. If you're a developer, you write the code, save it, save it and push it. You get the results within a couple of minutes. So that's what continuous integration is all about. Again, as a concept, it's easy to understand, but implementation is not that simple. It requires a couple of things. It requires the framework. It requires a tool such as Jenkins. It requires a testing framework, maybe Selenium, and then it requires a lot of automated testing framework. Jira is one of the very popular, extremely popular tools when it comes to project planning and issue tracking. So yes, it's worth learning and having experience on Jira, right? But as I said, just like any other tool, Jira would be maybe 2 to 5% of the overall DevOps, right? Because we have 10 to 12 different tools or the technology stack which we need to understand. CI tools, as you can see, we have a couple of them: GitLab CI, Jenkins, TeamCity, CodeShip, Bamboo. These are some of the most popular tools. You do have actually a lot more than that, but these are some of the most popular ones. And among these, if I would say the one tool which stands out is Jenkins, without a doubt, right? I would say like more than 50, 60 or 70% market is captured by Jenkins. One of the oldest tools, one of the most popular tools, open source, free of cost, highly customizable, right? You can do a lot of things in Jenkins, and you can get up and running with Jenkins within a couple of minutes on your laptop. That's the beauty of it. This is the comparison given to you, Jenkins versus Bamboo versus Travis CI. But as I said, why Jenkins stands out would be, some of the reasons would be open source. We have something called multiple plugin support, which basically means that Jenkins is a tool which is the architecture. We call it as a pluggable architecture. So you want some functionality, you install the plugin. You don't want that functionality, you remove that plugin. That's how it works. And installing, removing these plugins and all, it's like 5 minutes or 2 minutes task to you. Great community support. Jenkins, I have seen, is one of the most vibrant and one of the most active community on the internet. And even though it is free of cost, and of course you can't get a vendor support per se, for that you have to purchase the enterprise version, which is CloudBees. For the people who are not aware, let me just write that down. Cloudbees.com. Just check it out. This is the company which gives you the enterprise version of Jenkins. You could call it that way. Jenkins.com will be, or .io will be the open source. Cloudbees.com will be the enterprise, right? And supports all sorts of repositories. So any tool, any technology you can think of, you will find that Jenkins supports it already for you, right? That's the main reason why Jenkins is so popular. Continuous deployment, it takes where continuous integration finishes. So let's say you have done the continuous integration, you are running your test cases. Now when you run a test, what is the possibilities of outcome? There are only two possibilities. It can be a failure or it can be a success, right? So if it is a failure, of course it will go back to the developers and they will make the changes in their code, they will do the bug fix and all those sort of things, and then it will they will again commit and push the code for the further testing. If it was successful, it will move ahead in the value chain. So from there, it will be do the testing, UAT, QA, and finally deploy to prod. So all these steps as a whole, we call them continuous deployment, right? And you need to automate, you need to do a lot of tool integration and those sort of things before you achieve this. If you remember, starting of the class, I told you one terminology called one-click deployment, right? So one click would mean that the first block where you have the team of developers working on the code, the moment they click on commit, from there onwards, it should be completely automated and it should go to the fifth block, which is deploy to production in an automated fashion. If you have achieved that, you can safely say that you have done continuous deployment, or you are already doing one-click deployment. If not, then of course, let's say if you have multiple steps and multiple approval steps to be involved, you have multiple tools which you need to kind of work on before you achieve the final stage of deploying onto production environments, then you say, okay, you have not yet achieved continuous deployment. There are a couple of things which you need to take care of. The tools, again, the market tools, if you talk about, you have Puppet, Docker, Salt. Now, if you see in the screen, Puppet, Ansible, Salt, and Chef, all these 4 tools, they are the market leaders when it comes to configuration management. Now, they help you in deployment as well. When we talk about Docker, Docker is primarily a containerization technology, right? We call it in popularly known as Dockerizing your app, right? So category-wise, these tools are different, but they all help you in deployment in one or the other way. In fact, this is one common problem or one common challenge faced by people who are new to DevOps. You will find a lot of overlap between the tools. For example, you can do deployment with the help of Jenkins. You can do deployment with the help of Chef as well. So where is the difference? So there will be overlap in functionality. You should not get confused with. CI is CI, CD is CD, CM is CM. But a lot of things which Chef can do, Jenkins can also do. A lot of things which, let's say, Puppet can do, probably Docker or Docker Swarm can do. So that is something which will come after spending some time in the with these tools. You will understand where exactly is the functionality of a configuration management and where exactly it became a deployment tool as well. Okay. So this is a pictorial representation of a typical pipeline. I think we have spoken a number of times about it, so I'll just walk it through. So you have version control, then you build the tools, and then you have unit testing, you have deployment. This deployment is basically deployment to your machines like QA or pre-prod, UAT, all these machines. Once that is done, you have further sets of testing, then you finally deploy to production machines. And once that is done, of course, there is one very important post-deployment work, which we call as measure and validate. So once you have deployed things onto production, the work does not end, right? You still monitor your application, you still monitor your infrastructure, you still do stress testing on your application performance management, APM as we call that, right? So all those things go on. So that is the last and the final step of your overall CI/CD pipeline, right? And then the whole process gets repeated. One important thing to understand here in this slide is that at every stage you will find that there is an arrow going downwards and then it is going backwards. What does it mean? That you can actually give feedback, or you can provide feedback to in the pipeline at any stage of of your deployment or a CI/CD pipeline. That's what it means. Another representation, same CI/CD pipeline, but in a little bit more technical representation, where you have code which is being committed and you have the related code. Then it is being built and tested. Then finally it is being put into the staging and production lines, right? So same thing, but in a little bit different format to make you understand a little more on that. Right. So you have, as I said, it's CI/CD as a concept is very easy, but to implement, you need to understand a lot of moving pieces. There are a lot of moving pieces for a CI/CD pipeline which you need to integrate properly. Right. And that's where the DevOps engineer's expertise and experience comes into picture. Then, of course, we have again, we can't go too much into the containers. This slide basically talks about the differences between, if you see the green one, that is the architecture of hosting an application on a virtual machine, and the right-hand side, which is the blue diagram, it's actually architecture of an application deployed on containers. Okay. So again, in the interest of time, I can't go into much depth into these technologies, but I can tell you one very important thing which I have again seen whenever I take interviews. People talk about virtual machines and containers, but one crucial thing which they miss almost always is what is that key difference. And the key difference is when we talk about the traditional virtualization, such as VMware or something, that is actually hardware level virtualization. Okay, let me write that down so that you have it in your mind. So when we talk about VMs, so when I say VMs, I'm talking about typically VMware or Hyper-V or KVM, all those, right? This is your hardware level virtualization. When we talk about containers, on the other hand, the new technology, Docker, Rocket, Kubernetes, Docker Swarm, Mesos, when we talk about these, we are typically talking about OS level virtualization, right? So basically, your kernel gets virtualized when you deal with containers. Okay, so this is something which you should have in your answers wherever you're talking about VM versus containers. This is one thing which you cannot miss. Okay. Okay, since my screen is not visible, I will put it here. I hope everybody got that right. In fact, let me put these as well. So this is the list of kind of the topics which you should be checking out on Google. Just Google them and do a research on them. Try to find more information on them, right? And these are the companies which are worth following on Google, blogs, Twitter, anywhere, YouTube. They put enough material. They are the companies who are the game changers of the industry. Okay, so follow them. Make sure you follow them in any of the things listed. So again, this talks about the Docker architecture. We have multiple things again. I mean, I can't go into too much of details here. So the major, if you talk about the moving pieces in Docker, you have a Docker image, you have a containers, you have a Docker file, which helps you create Docker image, and from an image you create a container, right, which is the actual workhorse. So container is, you can say loosely, container is like a very lightweight or ultra lightweight virtual machine for you. Okay, but yeah, that's the end of the comparison. After that, everything is different in a container and in a virtual machine. So that's about it. Then, of course, I don't need to talk much about the monitoring side because you all know why we do monitoring. We have already spoken about the tools, right? So, no need to do any sort of deep dive in this particular slide. Demo, unfortunately, I will not be able to show you because, again, as I said, it will take easily 5 to 10 minutes. So, we'll skip the demo part. Maybe in some other webinar or some other session, but not today. Unfortunately, we lost about 10 to 15 minutes when we were starting the session. But yeah, that should not be a problem. You have enough information available online. You can just check it out. And any questions, any technical questions for me before I pass it on to the Magna team?
Hello. Hello. Hello.
Okay, can you guys hear me?
Yeah.
Okay, great. One question I have from one of the gentlemen, which is the most important thing DevOps helps us achieve? I would say high velocity. When you are writing softwares and it is going to the end users, that is something which you do at a Okay, so that's something, and I would recommend you to go and check some of the definitions from Amazon. Amazon has got a specific section on DevOps. Just go and search on Google, you'll find that and see. And one important thing, a lot of these companies which I mentioned, they have a lot of white papers. So I would strongly recommend you to read those. Right? That will give you very good information in general, what exactly industry is doing and where we are heading towards. Okay. Alright guys, so thank you so much, and if you have any further questions, feel free to reach out to us with any of those links. You can send us a mail, you can check out that link, and you can call up on that number as well, right? And you can get more information from there. And yeah, I have given you, I guess, enough things to search upon, right? So feel free to do so, and that should be a good starting point. Okay, so thank you from my side. I hope the session was good and informative, and you do have some good takeaways from the session. All right. Thank you. Have a good day. Bye-bye.
Thank you, Sharik, and all our participants. You will all receive a survey asking for feedback on this event. Your insights will help shape the future events such as this. We will send you a link to the recording of this event so that you can share it with your social networks as well. The recorded session of this event will also be available on YouTube. So on behalf of the Magna Infotech Career Services team, we thank you for joining us today. We hope you found this information and dialogue valuable in enhancing your understanding on DevOps. If you're interested to know more on the topic, do check out our DevOps course on Magna Infotech Career Services portal, mics.magna.in. I think it is displayed on the screen currently. Please make a note. There would be special discounts available for those who have attended this webinar. So with this, we come to the end of this session. We sign off and wishing all of you a wonderful day ahead. Thank you very much.